Hey, Physics Studies, welcome to the last video of our assignment solutions here. So we are going to just do some isotope insertion here just to make sure you did this well. Make sure you're balancing the top numbers, those are your nucleons, and balancing the bottom numbers, which are your protons / charge. Okay, so, wow. Yeah, so let's look at what we have here. So remember, the 3 in the front just represents that we have 3 of these. So on this side of the equation, maybe I should use the pen instead. So my head's kind of moving around a lot here. No. There we go. Okay. So on this side of the equation, we have 265 plus 3 ones. That's everything we know on that side. So I'm just going to add those together. We get 268. I don't know why I pulled out my calculator. Okay. The bottom numbers there are going to be pretty important too. So on this side here, I have 180 on the bottom as well. Okay. So those are the bottom numbers. The top number on this side so far, we have 208 plus something we don't know. It's got to add up to 268. So it kind of looks like that's going to be 60, just based on what we have there. That top number is going to be 60, and the bottom number is going to be 82, plus some other unknown number. So let me just double check that one there. 98. So we got a 98 on the bottom here. Do we have a 98? Oh, it's 108, not 180. What was I thinking? We gotta fix that. There we go. 108. Oh, 108, because 98 didn't seem right at all. That makes more sense. We got a 26. So we have a 26. So to find out what this is, I'm just going to go to my periodic table. Let me just do it for a second. Iron. So this is going to be Fe. Okay, awesome. Next one down here, we're going to do the same process. We got 9 plus 1. We have 10 on the top. It's got to equal 6 plus a question mark. So we got a 4 there. Then we got a 5 on the bottom here. We have a 3 plus a question mark. This is a 5, right? So it looks like a 2. So this is going to be a helium atom or nucleus. So alpha particle. If you want to write it differently, you could. Here's an alpha particle too. Okay, so we have 18 on the top. We have 9 on the bottom. Just add in those numbers. We have 8 plus a 1, so there's got to be a 1 there. Okay, and then the top here, we have 17. So I need a 1 to go with that. So it's going to be a hydrogen atom. Hydrogen 1. How much energy is being released in this reaction, this fusion reaction that produces what is I? Iodine, and Y, yttrium? I don't know how to pronounce that as a Y in it. It's the first letter. Gotta find it too. It doesn't really matter. They give us all the numbers on our periodic table, or right here, the masses that we need. Even here, I've rounded the neutron number for you, so we don't have as precise answers as we usually do, but still works. Sorry, I put my hand in front of my face. My face disappears. So the mass before is equal to, I had this number before, but we're gonna use these numbers here. So that's not the right number to use. We're using uranium 235. So that's 235.044 plus the 1.009. So I'm gonna add those together. I get 236.053, I believe. That's just my old math, right? Carry the 1 over, do all that stuff. I'm just going to punch in my calculator here. Yeah, okay, so we got that number. The mass afterwards. So I'm just going to add the iodine here. I'm going to add that to the yttrium. That's how you pronounce it. I don't know. And we're going to add that to 3 neutrons. So So 130.906. Oh, yeah, someone mentioned that my 6s and 0s could look the same, and they do sometimes. Oops. 101.934, and then plus 3 times 1.009. Blam! And we get 235. So we've lost mass. Where did that mass go? Well, it went into energy. So let's find out how much mass we lost. I'm going to minus these two numbers. So 0.186 atomic mass units. We got times it by 1.66 times 10 to the negative 27. 3.087 times 10 to the negative 28 kilograms. And then I'm going to use this formula to find the energy released. 2.78 times 10 to the negative 11 joules. And just because sometimes I like to communicate using electron volts, because it's still a pretty small number of joules here, I'm going to change it to electron volts by dividing by my number here. We get 174 mega electron volts. Okay, so get 174,677,000, et cetera, electron volts. Just change into mega. Cool. Check out this next question here. Chalk River, blah, 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 produces about 2/3 of the world's medical radioisotopes. They use molybdenum. Molybdenum. Is that how you pronounce it? Or is that how you spell it? Where's Molly? What's Molly 99? 99. Where is that? Oh, it's M-O. Yeah, it is. Cool. Oh, yeah, okay, right. I thought maybe I forgot an I, but I didn't. Okay. Not too really concerned, but it is, in this case, element number 42. But here we have a little graph. We have a chart here. It says construct a graph. User graph. So construct a graph, I know you can plot it here. You can make a little chart here. That's 1, 2, 3, 4, 5, 6. So it's a 10 by 10 table. Yeah, I could do this. Let's just create this really quickly here. So we got time in days. I got to figure out what my scale is going to be there. Here I got activity in becquerels. I got to figure out my scale here. I got to go up to 2,000. So I'm going to just put 2,000 at the top here because I know there's 10. So we have 1,000 here. So what are these? 2, 4, 6, 8, 10. Yeah, so this is 200, 400, 600, 800. Right. And then this is going to be 1,200, 1,400, 1,600, and 1,800. Okay, it's fun. You got to watch me make a graph. I got to go up to 24, but there's 10 spaces. The scale's kind of nice. It goes by sixes here. 0, 6, 12. So I'm thinking, yeah, we probably could use the 24. I could put 24 here. I could put 12 right down the middle. But where would I put? Oh, that's gonna be tricky. Where would I put 6? 6 would be right here, and 18 would be right halfway points there. Not liking that. But they are nicest numbers. So what I'm going to deal with here, I'm going to move my label out of the way because it's getting in the way of my numbers. Just move it lower. 2. How many numbers do we have? 5. 2. Oh, what am I messing up on before? Oh, yeah, 0. Okay, so 0. Yeah, so I'll put 6 here, 12 here. I'm not going to use all the bottom, but that's fine. I'm using a lot of the graph, though. Okay. This is fun. Where's this? This is 500. Right about there. Make my dot pretty big for the error. 12. Oh, where am I at 0? 0 is way up here. That's a pretty big drop. And then down to here, we got 90. There's 100. 90 is right about there. And then I got 19. That's 100. 50. 24. 19 is like almost right on the axis here. 4 is pretty much right on the axis. So this is what my graph's going to look like. Oh, not connecting dots, but we are going to curve it nicely. And then have a little asymptote here. There we go. Now, sure, I can read this. It looks like it could be a 3 for my half-life. But it says here you use an appropriate regression to determine the half-life. So what I'm going to do is I'm going to pull up a calculator. Hopefully I've showed you how to do this during the Half-Life lab as well. I gotta find calculator. You can do it Desmos calculator, however you want to do it. Let me do it by Desmos because most people did that using their lab. Let me just sign into my Desmos here. Sorry, guys. Taking a little bit of time. What do we have here? Desmos. Exponential regression. Open the graph. Okay. So I'm just going to put my data in first, and I'll show you what the graph looks like here. Technically, what I typed in too. So if you weren't paying attention, 0, 6, 12, 18, and 24. Mess up somewhere. 0, 6. This is weird. It does look pretty good, but for some reason, oh yeah, for some reason it's backwards on my chart here. We have to fix that, right? So hopefully, so what I'm going to do here, I don't know why this is this way. This is kind of strange. Okay, so this should be over here. That side. Oh, let me put it that side. There you go. I'll put it on that side. That's better. Let's do it that way. So you're gonna watch me fix your assignment for you. So hopefully, I print that off for you in the right direction. I'll have to do that after the fact. So hopefully, I remember that. Maybe I'll write that down right now. Fix table. All right, so I fixed my table and make sure my X's and Y's in the right spot there. So I figure out why that wasn't working. You could use a logarithmic regression that way. Why would I do that? Exponential regressions. 6, 19, 9, 4.21. Okay. There, it's much nicer looking graph. Much nicer R square, where the R value is perfect.
Oh my God.
All right, sorry about that. Came back as Donald Trump here. So we're going to construct this graph. I constructed the graph in Desmos already. So here's my graph in Desmos. I switch my X's and Y's around like I did before. I put in this down here. So what I typed out, you literally type out y1 tilde a bracket b to the power of, so you can just go shift 6 to do that, x1. You got to use the y1s and x1s because that's what's in the table up here, y1 and x1s. You can change these labels to what you want them to be, but you got to make sure they match down here. My r squared is 1, so that's good. We want the r squared to be as close as 1 as possible. My a is that, and this b, so obviously it's not a half-life equation because we're using 0.77, but it matches the data perfectly. And then here I put a line that is half of my a value. So if my a value is my start point, half is 1,000. So that point right there, the intersection point, just click on it. It's 2.7 and 1,000. So we're going to use that 2.7 as my half-life. There you go, because that's the time it took to come to half what it was before. So half. Oh, poop. Okay, let's fix that. And right in this here. So half-life is 2.7 days. Okay. Using your answer for part 1, determine the percentage left in the person's body after 30 months. So 30 months, or 1 month, sorry, not 30 months. 1 month is 30 days. So you can go back to the graph and find that, or I can use the equation to do this. It says using your answer from this part. I'm going to do that. So percentage-wise, I'm just going to end. I'm going to say I start off with 100%. Okay, I'm not going to put the 2,000 in there. I'm going to say I'm going to start off 100% because I'm talking about percentage here. And I'm going to go put in 30 days and 2.7. Okay, pull out my calculator here. And we get 0.045. And this is percentage because I had 100 there, so this is in percentage already. So I don't have to change. It's not going to be 4.5%. It's going to be 0.045%. All right, half-life of polonium-210 is 138 days, sorry. How much of a 20 kilogram sample of polonium-210 remains after one half-life? Well, this is just one half-life. So which is going to be whatever 200 kilograms times a half-life. That's just going to be 10 kilograms. That's a pretty easy number. Okay, after 300 days, okay, that's not a nice multiple of 138. So I'm going to have to put this into my formula here. So I start off with 20 kilograms, and I have 300 days, and my half-life is 138. So that's my equation I'm going to use. It's 20, what is it, 300 over 138. So 4.43 kilograms, okay, pretty good. And after 2 years, so this is a very key, you have to make sure you change the years into days. So that two years, and we don't know whether or not this it's a leap year or not, so we have to use the average of a year being 365.25 days. All right, so we just have to make sure that's okay, and 138. So I just times that by that number. I got 700 and some divided by 138. That says 138. There we go. Oh no. There we go. So we get 0.510 kilograms. Perfect. How many half-lives would it take for 10 grams to decay to 1.25 grams? So like I said before, when we don't do logarithms here, you can solve this question by using logarithms. Right, so solve for n being the number of half-lives here. We don't know the period or the time, we just want to know the number of half-lives. So we could solve for n, right? But I would have to use logs to do this if I wanted to do this algebraically. So because we know that this is probably a multiple of 10 or multiple, if I divide by 2, so if I divide 10 by 2, eventually I'm going to get this number. It's not a multiple. But it probably will be a whole number multiple of half-lives. So at 0 half-lives, my half-life count is 0 here. At 1 half-life, I'm at 5. 2, I'm at 2.5. At 3, I'm at 1.25. So 3 half-lives. Of course, you could do this by logs, but why would you? Okay. Everything looks good there. Okay, so hopefully you enjoyed all my videos. Hopefully. Maybe this is not the last video you watched, but if it is, it's sad. Donald Trump is sad. I'll see you guys later. I'll probably have like a goodbye video for you guys to watch as well. And I'll see you later. Bye.